You have a quiz due tonight. It's quiz number 2. Quiz number 1 was the assessment. Homework number 2 is due tonight. And it's on another website. It's xyzhomework.com. If you haven't made an account, there's still time to work on homework. Just let me know. We have all semester to get those assignments done, but just please try to keep up with the assignments. All right, I plan to post quiz 3 today, and it's due next week on the 21st. So it's next week on Tuesday. Same with homework number 3. Oh, cool. They have an answer. Yes. I think that's everything. I have notes to finish for homework 2, and then for homework 3, it's all about graphing. Okay, I'm also going to show you a table for translating from English to math. And I can also show you where past meetings are. So past meetings are in the modules on Canvas. Okay, here's the home page. In the first week, we have our first 2 meetings and the assessment quiz, quiz 1. In week 2, there's quiz 2 and our last 2 meetings. And then this week, we're still, doing the meeting currently, and we have this table, this page for translating from English to math. There's a few we've looked at already. We saw that is can be written as equals over on the right. Of is multiply. We're going to talk about less than, which is this. This down here, this less than, or fewer than, or as low as, is this symbol. If it says or equal to, then you have this little equal sign included. And then there's greater than, is here, or greater than or equal to. The last one, which we started to talk about, is if it says a number or how much or what, we're going to call that unknown thing X, or some kind of letter that represents the unknown value. So this will kind of help if you're going to be taking a stats class, or if, for our homework, you can use this table to translate. It's not a huge topic for this semester, but still, we're going to practice. There's nothing to solve. We just want to rewrite this phrase. Cool. 7 is less than the product of x and 5. Okay, here's color. So the product is going to be multiplication. And then we have 7 less than, strictly less than. And as we read from left to right, we're going to write the statement down just the same. Starting with 7. Less than the product of x and 5. So multiply x with 5. Translate the difference of a number and 2 is 4. Okay, so for difference, we're going to subtract. And remember, this means equals. And here's our unknown number, which we need to call some kind of letter. We're usually going to call it x. Start with let x be that unknown value. So the difference subtraction between that number x and 2, and put it equal to 4. Let's do that over here. So I want to do a couple where we talk about the quotient. So we translate the quotient of a number and 3 is 7. Of a number. I think I said 4. We're going to pick 4. Is 7. So for quotient, we're using division. you want to take the first value and then divide by the following value. Here we have an equal sign, equal to 7. So again, this is division. Here's an unknown number. So we're going to call that x. Okay, what do we have? Division between x and 4. X divided by 4 equal to 7. That's all we need to do right now. Rewrite that sentence. One more. So it's the quotient of 7 and x is 12. So we're dividing the first value by the following value and putting it equal to 12. Okay, it's the quotient of 20 and 4 is some number. Okay, so that part that says some number, we need to give it a name. So it's the first step is to define your variable if it hasn't already been done for you. We're doing division between 20 and 4 equals that number, x. Cool. Last one. For homework number 2. Oh, actually, never mind. I still wanted to talk about perimeter before we leave homework number 2. So the last one for translating from English to math. So it's the difference of 16 and 2 times a number. Is 5. So the part that says a number is our unknown value that we're going to call x. So we're going to just keep this here. Let x be that unknown value. So we're going to subtract between 16 and 2 times x. And have that equal to 5. Okay, so for the perimeter of a rectangle, it's the distance around this, let's see, perimeter is the distance around the edge of the shape. We're going to start off with just saying P is going to represent perimeter. And we're going to go right into talking about a rectangle. We're going to call the width W. Call the length L. It could be a lowercase l, but I'm going to pick a capital. Shape. Let's have this be the length. And this is the width. This is the same distance, L. And this width is the same here. Perimeter is the width plus the length plus the width plus the length. So 2W add 2L. Okay, so this problem will kind of help with your last homework problem, but it's a little different. It says that the width of a rectangle is 2 inches more than the length. Also, the perimeter is 40 inches. Find the length and the width. Okay, let's start with our variables, the things we don't know. W is width. Let's do it the other way. It's fine. It's going to be length. Let's translate. So the width here of the rectangle is 2 inches more than the length. 2 added 2. Yes, so whatever the length is, the width is 2 inches added to that. Cool. So now that we've gotten this rewritten, we're going to put down the formula for the perimeter and use that to find those unknown values. Perimeter is 40 inches, so we're putting that over here. And let's put in what we have W equal to, and that way we're in just one variable, L, and we can solve for L. Forty is equal to 2L plus 2 times the width, which is 2 plus L. And distribute that too. I have 40 equal to 2L. Add 4 and then add another 2L. So 40 is equal to 4L. And then we're solving for L. So let's subtract 4 from both sides. And 36 is equal to 4L. Like this. And divide both sides by 4. So 9 is equal to L. That was part of the question. The other part is to also find the width. Which was 2 plus L. And 2 plus 9 is 11. So the width equals 11. Cool. And that's the end of the notes for homework number 2. And we want to start notes for homework 3. So this is about graphing points and graphing lines. Points are ordered pairs. And we graph points on the rectangular coordinate system, which is also called the Cartesian coordinate system. It's somebody's name, so it's a capital C-A-R-T-E-S. Okay, so for your rectangular coordinate system or Cartesian coordinate system, you have an x-axis and a y-axis. This point here is the origin. And some classes may talk about the quadrants. So just in case, this is quadrant 1. Roman numeral 1, here's quadrant 2, quadrant 3, quadrant 4. And we're going to graph the following points. We'll graph 1, 4, and 0, -2, and -5, -3. Let's just draw a new graph. Okay, we're gonna need some units, kind of evenly spaced. And we're going 1 for x, and then up 4 for y. So over 1, 1, 2, 3, 4, it's right about. Next point is 0, -2. So we're going 0 for x, and then down 2 for y. Then for -5 in the x direction, -3 for y. 1, 2, 3, 4, 5, and then down 3, 1, 2, 3. So it's just a pretty good sketch. It's nicer on your homework where it's very like accurate on the grid. Okay, to graph a line, you need 2 points on the line, and then you can disconnect them, drawing straight through. After you find the points, you can draw that straight line through them. We want to graph y equals 4x minus 1. So you can find 2 points, and I can pick any number for x and then figure out what y would be. And let's try x equal to 0. And I'm going to pick x equals, maybe just pick 1. If x equals 0, I would have y equal to 4 times 0 minus 1. So y is equal to negative 1. Okay, here I picked another value for x. Any number works. And if it's 1, I'd have y equal to 4 multiplied with 1. Subtract 1. So y equals 3. So I just found 2 points. The first point is where x equals 0 and y equals negative 1. And my other point where x equals 1, y is 3. Okay, so I go 0 for x and down 1 for y. And then 1 for x and up 3 for y. And then connects the dots with a line. So that's one way to draw a sketch of that line. We'll talk about other ways later. Let's talk about vertical lines first. Yeah. So the graph of the line x equals some number, but we're going to pick a specific number. I picked x equal to 5. So this graph is the set of all points whose x value is 5. Scoot. This way. Okay, here, there's no y value. Y can be any number. And okay, so some of the points in this graph would be x equals 5, and y could be any number like -2. And I can graph 5, 0. Or like 5, +4. As long as its x coordinate is 5 and y can be anything. Let's do 5 and 7, and then, we'll connect those dots. Start with some units, kind of space them out evenly. Okay. X equals 5. 1, 2, 3, 4. And then -2 for y. Five, 0, be over 5, up and down 0 for y. Then we're at 5, 4, over 5, up. Here. Then I put 5, 7. So there's my vertical line going through all those points. It was the line x equals 5. So x is stuck at 5, y goes up and down. Y can be up towards positive infinity, or it can be some number down near negative infinity. And we're going to go over horizontal lines. Oh, one last thing though. The slope of a vertical line is undefined. So we want to go over horizontal lines. And I picked a specific example. So the graph of the line y equals, let's go with 2. So this graph is the set of all points whose y coordinate is 2. And there is no x value mentioned, which means x can be any number. I'm putting down examples of points that would be in that set. So points that we can plot on our graph. Y has to be 2. X can be anything. Like x could be -3. Or we could have like +3 followed by 2. We could have 2, 2. Or 0, 2. As long as y equals 2. All right, sketching a graph. Mm. Mm. Starting with the first point, -3 for x, and up to for y. +3, up to. And then 2, 2 will be here. And I did 0, 2. So our horizontal line connects those dots. And that's the line of y equals 2. So y is always 2. X could be some number that's negative. It could be some positive number. It can go either way. Any real number for x. And we've talked about solutions to equations, but now we're just going to restate what a solution is if a point is a solution. then it's going to be like a pair. That makes a pair of values that makes your statement true. All right, let's get that done. All right, the difference is that in an equation that has two variables, so the solution is a pair of values that make the equation a true statement. Okay, first one is the point -2, 1, a solution to. The equation y equal to x minus 1. So you're putting in 2 for x and 1 for y. And then check if that statement is true or false. I've got y equal to 1. On the other side, it's -2. Well, just -2, and then subtract 1. That's a false statement. So that point is not a solution. One more where we ask. The point 3, -4, a solution. Y equal to -3x plus 5. And again, let's just point out that 3 is our x value and -4 is y. I'm going to have -4 equal to -3 times 3, and then add 5. -9 plus 5 is -4. So this is a true statement, which means that 3 -4 is a solution. To that equation, y equal to -3x plus 5. Okay, I'm going to go on kind of a side topic. I feel like I probably should have gone over this maybe during review week, but we're just going to stop and talk about popular sets. I've been mentioning real numbers, so we're going to talk about what the set of real numbers is and some subsets of that. We start with the first set being the natural numbers. Those are counting numbers, starting at 1, over to 2, 3, 4, 5, and keep on going that way. After that is whole numbers. Is this set, and you put 0 in there. So start at 0, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And keep going like that. Okay, integers is this set along with all the negatives of those numbers. So we're coming from negative infinity, going like -5, -4, -3, -2, -1, 0, 1, 2, 3, 4. Keep going. 5, 6, 7. Okay, now we're at the rational numbers, which are numbers that can be written as fractions. We're just going to write it out. So this set can have 1/2, it could have -3/5, positive and negative fractions. Separate from this set is a set called irrational numbers, and they're numbers that cannot be written as a fraction. Okay, rationals, irrationals. If you put both of those sets together, that's called the set of real numbers. So real numbers is the irrationals and the rationals, all in the same set. Okay, some classes, not our class, probably not a stats class, or I guess I'd say, I would say that it's rare that a math class goes into the complex numbers, but sometimes a teacher might work in the complex numbers, which is just one set further out. And usually that's where we kind of stop doing, as a place where we stop working, like past that place. It's a little more tricky, a little more difficult to work in other sets. Let's see, complex numbers is usually where we stop as the set of numbers that we call imaginary. But again, our class and most math classes just stay here in the real numbers. And we're going to draw a quick picture of all of those sets and then get back to graphing. So we started with the natural numbers. As a set. And then we put 0 in there, which got us to the full numbers. Just a little bit bigger set. And then we had the negatives and the positives of whole numbers. So that's the integers. And then in here, we could take those and write them as fractions, and those were called rationals. Separate from this is the set of irrational numbers. And then when we put this set with that set, that's called the set of real numbers. So this is going to be my full universe, all real numbers. Okay, and all of that really was just to make sure we understand what integers are, but also I've been talking about real numbers and I want to just be more clear of what that means. Cool. So the example is to find two integer solutions. So two solutions. In this case, we're talking about points. And the solution is a pair of x, y values. X has to be -5. And there's no y value, so y can be any number, but your question asks for that number to be an integer. So it could be 1, 2, 3, 4, 5. It could be -1, 2, 3, 4, 5. It could be 0. Just as long as the x value stays at -5 and y value is some integer. Let's sketch a graph. -5, 0, -5 for x, 0 for y. And -5, 3, still -5 this way, and up 3 for y. Okay, let's find two integer solutions to y equals -3. Oh, cool. Question. How did I get 3? Oh, I picked it. It can be any number as long as that number is an integer. So I could have picked, like back to the previous problem. It was x is -5. And y equals any integer, which could be like -3, -1, -2, 0, 1, 2, 3. And I just happened to pick 3. But you can pick, -2. Let's go back. Let's do this one so it'll be a little more clear. In this problem, your two solutions are points, x, y points. Y has to equal -3. And x, it can be any number, but then this problem kind of restricts it to an integer. So like last time, yeah, and like I could pick 4. And on the last problem, let's put it here. There's nothing super special about it, but yeah. Okay, cool. I'm glad I answered your question. Yeah, the only goal is just that in this kind of question with the integer part, don't use any fractions or any decimals. Just have it like positive or negative counting number. Okay, let's, I only had to find 2, but while we're here, I'm gonna throw down a few more just for fun. You have something like 6, -3, 4. Something else, -3. Just again, no fractions or anything. Okay, let's use these points to sketch a graph. Label going 4 for my x value, down 3 for y. And then 3 is my x value, and then down 3 for y. And I guess I can just go ahead and just there and then over, yikes, that way, as straight as it can get, and then labeled with y equals -3. Let's call that good for today. So we're going to come back Thursday and talk about XY intercepts, the slope of a line, and just more practice with graphing lines. Okay, thank you for coming to the meeting, and